Norman talks about the importance of a conceptual model for an object. You can read what he has to say about it here. I'm going to paraphrase it. Basically, he's saying that the designer of an object will have a conceptual model of it, and the designer will try to design the object so that the object's image, what Norman calls the system image, will give the user the same conceptual model. That's the goal. Now, the system image is not only what the object looks like and sounds like, it's also what the documentation says about how to use the object. The user's conceptual model is formed by the system image and through how the user interacts with the object. And here he's just reiterating that the designer's model and the user's model are not necessarily the same, even though the designer would like them to be. The burden of communication, says Norman, is with the system image. Here's an example of what can happen when a user does not have an appropriate conceptual model of the system. Consider a refrigerator with 2 compartments and 2 doors, one for frozen foods and the other for fresh food. And inside the refrigerator, you see 2 controls. One of the controls is labeled freezer, and one of the controls is labeled fresh food. The control labeled freezer has settings that go from A to E. The control labeled fresh food has settings that go from 0 to 9. And the instructions you see in this slide are the instructions on the inside of the refrigerator near the controls. Let's take a closer look at the instructions. We see that the normal settings are C for the freezer and 5 for fresh food. That's right in the middle of both ranges, so that makes sense. If we want colder fresh food, we keep the freezer control on C and turn the fresh food control up to 6 or 7. Okay, so it sounds like the higher numbers mean colder temperature for the fresh food. Now if we want the coldest fresh food, we turn the freezer control to B and turn the fresh food control all the way up to 8 or 9. The 8 or 9 seems to make sense, but why are we messing with the freezer control? And why are we turning it down? Okay, let's move on to see the rest of this. If we want a colder freezer, then we turn the freezer control to D and the fresh food control to 7 or 8. Okay, to me that makes absolutely no sense. So let's just look at the next one out of curiosity. For warmer fresh food, we keep the freezer control on C, which is its default, and move the fresh food control to somewhere between 1 and 4. Actually, that last one seems to be more in line with the first couple of instructions. It's just the coldest fresh food and the colder freezer that really don't make sense. So, what exactly is happening here? See if you can come up with some idea of what's going on. You don't have to figure out what the exact settings do. Just see if you can figure out why there seems to be a discrepancy between the instructions and what we are expecting the controls to do. I'll give you 10 seconds to pause the video, starting now. Okay, this actually happened to Donald Norman, and he became so confused that he got a couple of thermometers and did some experimenting with the settings. By the way, before I continue, can you look at the instructions and tell me what very practical problem Norman must have come up against when doing his experimenting? No need to pause the video for this, but I'll give you 10 seconds to look at the instructions starting now. Okay, the problem I'm referring to is that you have to allow 24 hours for the temperatures to stabilize. Even if you're only going to test a dozen different setting combinations, that's going to take almost 2 weeks. Okay, back to the experiment. Norman played around with the refrigerator and he came up with this theory. Looking at the controls and how they were labeled, it seemed as if the freezer and the fresh food compartments operated independently of one another. That would imply that they each had their own cooling unit and they each had their own thermometer. But in reality, there was only one cooling unit, and one of the controls adjusted the cooling unit, while the other control adjusted the airflow between the freezer compartment and the fresh food compartment. So the problem with understanding the instructions was that the instructions and the labeling of the controls, which make up the system image of the refrigerator, suggest one kind of conceptual model to the user. That's the implied model on the left. But in fact, the designer was working with a different conceptual model, the actual model on the right.